Hey guys, okay, let's look at these different types of mutations, and I'm going to go step by step through the examples on the second page, basically the practice problems, and then you can just write this down, and then you'll have a worksheet where you'll actually have to identify the different types of mutations and what has changed inside the amino acid. So we'll take some notes and just follow along and write them down on your paper. So let's first look at this original DNA strand. We have to go through transcription first, so we have to make our DNA or our mRNA from our DNA. So T is going to be an A is going to be a U, C is going to be a G. U, C, C, G, A, U, U, A, A. So we've gone through transcription. Now we need to go through translation. So you're going to need to look at your codon chart and read these codons to create your amino acids, which is what that stands for. So amino acid is AA. AUG, you guys should know this by now, is MET or methionine or start. UCC is serine, so it's SER. GAU is asparagic acid, so that's just ASP, and then UAA is your stop codon. So this is the normal DNA strand that we're going to keep referring back to, or the normal amino acid protein strand that we're going to continue to refer back to on these mutations. Let's look at a silent point mutation. If you guys remember, a silent point mutation is where there is no change in the amino acid, in the resulting amino acid. So let's see if that's true or not. Here is the change I made. I changed the C or the G from the original DNA to an A. So let's see if that affects us. Again, we need to go through transcription first. AUG, UCU, GAU, UAA. Okay, AUG, methionine, that didn't change. UCU is still serine. It's still serine. GAU is aspartic acid, and then GAA is our stop. So again, looking at these four, they compare directly back, and there is no change. There is no change. That's a silent mutation. Now let's look at missense. Missense is where at the point of mutation, which is right here, at the point of mutation, there's going to be a change in the amino acid, and it's just going to affect this one amino acid. It's not going to affect the rest of these. So again, let's just figure. Let's look at nonsense point mutations now. So nonsense point mutations happen, or are caused, I should say, when a mutation occurs and it creates a stop codon. So let's just see if this amino acid, this change right here that I have circled, creates a stop codon. So we're going to have AUG, UAA, GAU, UAA. I think some of you can already see it just from the patterns I've been using. So AUG, methionine, and this is the stop codon. What this will do is actually tell the cell to stop making a protein, and the protein won't be created at all. So with a missense, or nonsense, I should say, no protein is created, and it creates a premature stop codon. Now with an insertion frame shift, we're actually inserting another letter or multiple letters. I mean, our body, it's not just one letter that gets inserted. It could be a section of letters, it could be a string of codons, whatever, that gets inserted. Here I have inserted a C. And what that has caused is all of these letters to be shifted over this direction to the right. So we're going to transcribe it now. So AUG, UGC, CGA, UUAA. AUG again is methionine. UGC is cysteine, so CYS. CGA is arginine, ARG. UUA is leucine. And then we can't code for this because it's not a complete codon. But basically what would happen is it would just keep going until it hit a stop codon. So here are two things that happen with a frame shift mutation. One, at the point of mutation, the amino acid from that point of mutation on is changed. And if we compare that back to the original, which is MET, SER, I don't remember what the other ones are. Anyway, from this point on, it changes. So the mutation affects all amino acids after mutation. Again, now let's look at deletion. It's basically just the opposite. I have taken out a letter here where you see the little caret on your paper. We still need to go through transcription. So AUG, UCG, AUU, and then UA. Again, this is not going to code for anything because there's not three letters. I mean, in our cell, it would just keep going until it hit a stop. So AUG is methionine, UCG is serine, AUU is isoleucine, and then we just keep going. So you can see it has changed. You can see it has changed from that point on. It has changed, and there are no stop codons anymore. No stop, not in our DNA code, but you'll eventually stop. And it does change. It does create a stop. All amino acids after the point of mutations happen in a deletion as well. Now what you're going to do is work on your worksheet. If you don't finish your worksheet, it is not homework. If you don't finish your worksheet, it's not homework. We'll continue looking at that later. I hope this helps you guys.